Well, now we're going to take a look at how to convert polar equations back to rectangular equations and vice versa. So let's take a look here. First, we're going to see that we have some formulas that are going to be very, very important for us as we attempt to convert equations. We're going to use this Pythagorean theorem relationship, r squared is equal to x squared plus y squared, and then our relationships on x and y and how they are equal to r's and thetas. Now, the common techniques that we're going to employ are often going to be one of these two, either taking an equation and multiplying both sides by an r to either create an r squared or r times a trig function, or sometimes we'll end up squaring both sides of an equation to try to introduce r squareds. You'll see how this works as we take a look here at example number 4. I want to write an equivalent rectangular equation for this polar equation. So this is some sort of a polar relationship that's happening here. If I plug in different values of theta, different values of r pop out. And I can kind of imagine this creating some sort of a graph, which we'll discuss in a couple videos. So if I take a look at this, if I wanted to figure out what sort of rectangular equation with x's and y's that equivalent to, well, I might start by doing the following. I will say we will multiply both sides by r. If I was to do that, notice I would get r squared on the left, and I can write this as 2r cosine theta on the other side. What that allows me to do is it gives me r squared, which can be substituted out for x squared plus y squared, but it also gives me this r cosine theta, which I can substitute out for the value of x. So if I was to take this and do a transformation with it, I can see that the other side is now x squared plus y squared is equal to 2x. So actually at this point, I'm completely done with this question. I've taken an equation that had only r's and thetas, and I've fully transformed it into something with only x's and y's. Everything now that I'm about to do is completely extra, because I might ask the question, what sort of picture does this thing actually create? And well, one thing that you might see is that if I kind of group together all of my different x's and my y's, and I set things up like this, notice I just moved the 2x over to the other side, I could actually do a process of completing the square, and I could then go ahead and see that I'm going to get an equation that looks something like this. And you might be able to tell what this is. This is a circle, specifically with a center at 1, 0 and a radius of 1. So this polar equation up here is the exact same as this circle equation that we have in rectangular coordinates. You'll see here then that sometimes what we'll find is that polar equivalents of some very common sorts of rectangular shapes are actually going to be a lot simpler. This 2 cosine theta graphs a circle instead of this more complicated rectangular equation.